So hello, I'm Victor. I'm the person who will present this webinar. So I suppose that you can see my screen. I'm going to divide this webinar in several steps. First, we are going to do an overview, to make an overview of the workflow that we have designed in order to develop acoustic projects into an Open BIM workflow. So I'm going to explain you the applications and the BIMserver.center platform where we can make all the connections with the parts and the professional that takes part into the project. After that, we are going to go to our open or architectural modeler, which is open CYPE architecture. After that, we are going to show the step needs to go into the acoustic simulator tool, which is Acrobat by CYPE. So if you're okay, we are going to start. First of all, I'm Victor. I'm in charge of acoustics in the CYPE development department. I'm the person who developed Acrobat by CYPE in this CYPE company, because this is a collaboration between CYPE and the CSTB of France. So I'm going to show what we did in terms of acoustic simulation and how it works. Okay. So this is the presentation. We're going to start. Okay. So well, first, as we are going to focus on Acrobat, I would like to tell you that this is a tool which aims is to calculate insulation and acoustic conditioning of buildings in terms of the national building codes of most of the countries. So we are going to focus on the insulation, on the different levels, and about airborne noise and impact noise. And then we have a part of acoustic conditioning, like reverberation time or acoustic absorption area. That is not the main objective or the main goal of the application, because it's more focused on the insulation, but we have some general indices that are need to check the building codes. So to start a project in Acrobat, we need an architectural model, okay, an architectural BIM model. I mean, when I'm talking about BIM in this presentation, I'm going to talk about the standard LSC in the part of the architectural model, because it's what we need in Acrobat. So I see the standard, the international standard of BIM, and we have some applications in set of types that are free available for our users, like CYPE architecture or IC builder, where we can design a building for Acrobat. The difference between both applications are CYPE architecture is an architectural tool. I mean, it's focused on the design. We can create complex buildings, and then the only disadvantage of this is we had to create an analytical model after doing the architectural design. On the other hand, we have IC Builder, where we can create a building thinking about acoustics and thermal simulation. So this is more an analytic architectural model, okay, where we have a simplification of the building. In this case, we don't need to create after that an analytical model, because with this architecture we have both the architectural and the analytical model. inside one software. The only disadvantage is that we couldn't make complex buildings. Then we have other applications from other manufacturers which can work with IDC. We have Autodesk Revit from Autodesk, and in this case we have a plugin to use in Revit, which help the user to upload the IDC into our platform, BIMserver.center, where we need the files in order to go into Acrobat BIM and make the simulation. And if you are using a different three-party application, BIM application like Allplan or ArchiCAD that we have here, we can use another free application, which is IDC Uploader, where we can upload any type of IDC into BIMserver.center. Okay. Well, this is the workflow of Acrobat BIM. Sorry, that we changed the name, so it's now Acrobat by SYPE, not Acrobat BIM. Okay. So first of all, what I have is here in Spanish. Okay, but it's the architectural model. So we need to choose an application in order to make this architectural model. In this case, we are going to use SYPE Architecture. Okay. Once we have choose the application, we need to develop the architectural model. What depends on our workflow, maybe we only need to wait the architecture to give us this model, or we have to make it. So we are going to do it. We are going to use SYPE Architecture in order to design this architectural model. Once we have it, we are going to export it into BIMserver.center. So previously, we have to create a BIMserver.center project. I told before, but BIMserver.center is the nucleus of the Open BIM workflow inside. Okay, all the applications are connected with BIMserver.center, and we can import, export files, and share it with the rest of the teams, of the teammates. So after we use an application, we export this information into BIMserver.center, into our project of BIMserver.center. So we need to export it. And then, as we are using SYPE Architecture, we need to import this architectural model in IFC format into Open BIM Analytical Model. This is a free tool that we are going to put in the middle of the architectural model and the acoustic simulation tool. This application will transform the architectural model into a geometrical analytical model. I'm talking about changing the typology of the elements. I mean, as we introduce in the architectural model architectural elements like walls, slabs, windows, doors, okay, we are going to transform it into surface, and unions or connections, links into that surface. So this is the aim of this Open BIM Analytical Model. Once we have this surface and adjacency conditions, that is what we need in the acoustic, also in the thermal simulation tool, we are going to export this analytical model again in the project of BIMserver.center, and we will go to Acrobat by SYPE. Here we're going to import the analytical model, and then we can work directly with Acrobat. I have also introduced other applications that are connected to Acrobat by SYPE to let you know other ways or other type of information that we can read. For example, we can introduce a definition of the construction systems directly in other applications, and we can read it in Acrobat by SYPE. We can introduce the water equipment because maybe we need to calculate the compressor level of the bathtubs. We can introduce the HVAC installation in HVAC ductwork. All of these are applications that are available in SYPE from the BIMserver.center store. I will show you that. So we can use SYPE HVAC to introduce the HVAC installation in order to calculate the compressor level in grills and diffusers. And then we can introduce the machines in SYPE hydraulics again to calculate the compressor level. So once we introduce all the information into Acrobat by SYPE, we can make the analysis of all the airborne noise, impact noise, insulation, the reversion time, the typical indices of acoustics. And once we have finished this simulation, we can generate the reports and export it again into BIMserver.center to share it with the rest of the team. So let's carry on. Well, here's some information about the elements that we can introduce from the different application. So we are going to use the spaces of the architectural model, but the elements of the analytical geometrical model from Open BIM Analytical Model, and then we have the extra element from the other applications. And we will get from Acrobat the justified documents and the 3D model. The 3D model is available in the BIMserver.center platform. So this is the presentation, and we are going now to start using the applications. So I'm going to look for the architectural modeler. So we are going to visit BIMserver.center. So this is BIMserver.center. I have my account here, but you can register and use it as free as I will show you. So I recommend you to register in BIMserver.center before. Well, I recommended you to do it before this webinar, but if you didn't do it yet, you should do it because it's need to carry on with the workflow. Once we are in the BIMserver.center, we need to go to the projects tab. Here we have all my projects, and we can create a new project. I'm going to call it for example, acoustics webinar for 26. Okay. You can introduce a description and the type of project. In this case, it's a test. Okay, it's not a professional project because we are not going to construct this building. Here we can set the views options. We can let it visible for all users of BIMserver.center or only for the people. Well, we can let it for all users, independent, without taking into consideration if they are registered in BIMserver.center. We can let it visible only for BIMserver.center user or only to all contacts, or let it close. Okay, I'm going to let it totally visible because this is an example I could say. And we can let the collaboration request open. It means that we can let the other people of the BIMserver.center send us collaborations. Okay, so we have created the project, and now we need the application. So to get it, we can go to the store here, and we can look for the application. We can look for the architecture. Sorry. Here, and we can look for Open BIM Analytical Model tool. And finally, to Acrobat. So here, for example, in SYPE Architecture, we can download the application And we can check the available resources if we don't know how to use it. And we have here all the links to the rest of the webinars, the tutorials, the papers, information, documentation, so we can check it. Here we have link of interest from the blog of BIMserver.center, some tutorial, well, a lot of tutorials, seminars, and courses. It's the same with CYPE architecture, with Open BIM Analytical Model, and with Acrobat BIMserver. So I recommend you to check this information before using it. So we need to download the free application. I did it before, so I have it here in my desktop. So let's start. I'm going to open a CYPE architecture. Well, now it's warming because there are a new application of CYPE architecture, and it has as if we want to update this application. I'm going to let it for the moment. And here we have the model that we are going to use in Acrobat. I'm not going to draw a new model because we have other webinars to show you how to work with CYPE architecture, and if I'm focused on this, we don't have time to focus on the acoustic tool. So here we have an example. I'm going to show you the 3D view. Okay, this is the 3D view of the building. We are using this in some webinars. So if you visit the tutorials of CYPE architecture, you can see how we develop this project. So here we have the elements. Okay. So information about the spaces. And here we have some views. Okay, for example, the sections. Okay. And here we have the floors. Okay, we can see the reference of the spaces, and if we go to a wall, for example, we can see the properties, the level, and the type. Okay, the typology. This is important because when we are in Acrobat, we read these typologies in order to assign it properties. As you can see here, we don't have any information about the acoustic reduction index or the impact noise properties, for example. So that's because we need to introduce this information in the specialized tools. In this case, Acrobat BIMserver. So here we only have properties and, well, geometrical values. Okay. So once we have this information, this architectural design, we need to export it with this tool. Okay, well, I didn't show you, but we have some tabs for architecture. But in all the tabs, we have these tools to update the project and to export the project. Then we need to update it. Okay. We need to set the BIMserver.center project. So I'm going to select a project, select a project, and we select this acoustic webinar that I've created before in BIMserver.center. So now we are linking the CYPE architecture project with the BIMserver.center project. Now we have finished this linkage. Now we need to export it. Okay, here we can set a name for this file or for this collaboration, more because it is a package of files. So we can set this architectural model. Now we are going to export. We are transforming the elements of this project into IFC elements and GLTF elements. The GLTF is the format that we use to create the 3D views in the BIMserver.center platform, and it's used by our mobile phone applications or augmented reality applications. because I didn't told you, but as when you export a building or a project into BIMserver.center, you can show it in several devices as your mobile phone and as our augmented reality application that are totally free. So we are waiting to export it. And once we have it finished, we are going to pass into Open BIM Analytical Model, where we are going to create the analytical model. I have here. Okay, I'm going to close. And here is the project. So we are waiting to have the content in the BIMserver.center project. For the moment, it's empty because we are doing this presentation. But once we have it, we will have a new file in this list. Okay. This because we have a synchronizer here that you can see now, which is the program that upload the files into BIMserver.center. Okay. You can see here that we are uploading this architectural model. Okay. Because this is finished, and we have to wait the process in order to end and to have it in BIMserver.center. Okay. Here. So now you can see that we have this architectural model. If we go to the dashboard, we can press to the 3D view. Okay, and we can see here the model. So we are going to pass to the second step. I'm going to open BIM Analytical Model. This is the second program. Here we need to create a new project. Okay. I'm going to we're going to select the project, the BIMserver.center project, the same project that we did in a CYPE architecture. This is exactly the same. Now the software is reading the files. Okay, let's wait a second. This could take some time depending on the complexity of the building, but once we have read the data, we can work without waiting anything more, because this is a process that we have to take into consideration, because we are not reading a native file. We are using an international standard as like the IFC. So we need to export this information into an IFC, and we have to read this information in the other application. We want to do it by this process, because this is something that help the user to maintain the versions and to maintain the information without taking into consideration the applications. Okay. So once we have read it, we can carry on, accept it, and now we are obtaining the data of the SC model. Okay. So let's start. I didn't tell you before, but if you have any question, you can let it in this in the GoToWebinar tool, and I will answer those questions after the presentation. So now we are in Open BIM Analytical Model. We can have a 3D view of this model. This is exactly the same type architecture. Okay, but now we need to transform this model into other type of elements like surface, edge, to make unions. Okay, to introduce holes, to introduce hole elements, to introduce the shadows. Okay, so you can make it manually. We can introduce surfaces, we can introduce spaces. Okay, totally manually. But as we have an ASC, we can try to use the automatic analytical model generator that is available from this button. So I'm going to save this project and we're going to use it. Here we have to select the spaces that we want to generate. We can see a list of spaces from the architectural model. Okay, all of these spaces have been defined inside the CYPE architecture. And here we have some extra options. Generate external surfaces for the shadows. We can introduce edges for acoustic and thermal, okay, for the units, and we can for the joints, and we can generate the surface of the shading elements. In this building, we are not going to have some shading elements, but I'm going to let it check because it's the default option and it's not a problem. And here we have an extra option in case we have a CFC model with the second level surfaces, but it's not the case. We can use it if we are going to introduce an IFC model from IC Builder, for example. Also, IC Builder could pass directly to Acrobat by side without passing without going into an Open BIM Analytical Model. Okay. It's only if you want to modify the analytical model of IC Builder. So here we are going to transform the architectural model into an analytical model. So we need to analyze these spaces. We need to analyze the construction elements like walls and slab, and to detect the surface of those spaces and the typology of those surfaces in order to create this analytical model. After that, we need to create the adjacency conditions to know what spaces are connected in order to calculate after that the acoustic and the thermal transmissions. And finally, we analyze the surface in order to get the edges for the lateral transmissions. So now we are going to generate surfaces. Okay. This is the same. This is a process that will take more time depending on the complexity of the building. I'm not. I'm showing you all the process in order to don't interrupt the workflow, because I would like to show you all the steps without making any trick. Okay, but of course this is a process that you only need to do once, because after you have the analytical model, if you don't modify anything of the architectural model, you can use it directly in all the specialized tool for thermal and acoustical simulation. Okay. Anyway, as it will take longer, I'm going to use it to use the analytical model that I've created before. Okay, because it doesn't make sense to wait until finish. I will show you when it's finished, but I'm going to pass directly to Acrobat by side. Okay. So here we are in Acrobat, and we can start a new project. It's the same that I did with Open BIM Analytical Model, but as we have seen before in the workflow, I will remind you, we have created the architectural model. We are generating the analytical model now, but I will use the same analytical model, but generated before. And now we are going to pass into Acrobat BIM by SYPE. Acrobat by SYPE, sorry, this is Acrobat, okay? And to do that, we need to read the Open BIM Analytical Model. I'm going to create a new project. I will call it same webinar. Okay. Accept it again, and we select the project. I'm not going to select this because we didn't have finished the analytic. Well, yes, we have. Okay. So now I'm here in the analytical model. I'm going to hide the geometrical elements, and we can see here the analytical elements. Okay. So as it has finished before, I'm going to show it better. For example, now we have surfaces. If I press into a surface, we can see the reference, the type that we have read from the architectural model, the type of surface, if it's opaque or glaze, if it's an element in an opening or it's external, the space where the surface is assigned, and the adjacency, if it is adjacency to the external, in order to calculate external noise, if it is if its adjacency is with soil, with parting, with a surface, with another surface. Here we have the position, okay, and then another geometric parameter that we can calculate, that is have been calculated before. These are for the surface. If I in an internal surface, here we can see that we have another surface of coordinates of adjacency. And here, if I press into an edge, we can see the different elements that are in this edge. Okay, the surface 1, the surface 2, and the rest of edge that conform these junctions. And finally, the length. Okay, so this is the analytical model. When we have the analytical model, we can export it into BIMserver.center. Before we can introduce here the zonification or the use unit that we need in the rest of applications. So to do that, we can manage these space groups, and we can create a new group as use units, where we can introduce the different use units of the model. For example, this F1A, that is 1/2. Okay, well, so we can here press it and assign all these spaces to one use unit. Okay. Doing this, we avoid the calculation of acoustic indices between these spaces because are from the same owner, are from the same use unit. Okay. So we need to do this for the rest of elements. I did before, so I'm going to save it and I'm going to open another one that is exactly the same but with these use units. Okay, so I'm going to manage. I'm going to see using, and you can see here like we have F1, F1B, F2A, F2B, F2. Okay, all these groups of spaces, the common areas and the garage. Okay, and we can see it in the 3D view. If I press here the representation, use units, and we can see here the different use units in different colors. Okay, I'm going to hide the external surface. Okay, now we can see better. So when we have this model, it's the same as we did before in the architectural model. We need to export it into BIMserver.center. As we have it linked to other projects, I'm going to change it. I'm going to change the project in order to export into the project that we are developing now. But anyway, I'm going to carry on with Acrobat, and I'm going to change into this project because we will have sadly the same result. So instead of using Acrobat Webinar, I'm going to use this into Open BIM. Here in Acrobat, we need to select, instead of the architectural model, the analytical model as a main file, okay? Because we are going to work with this Open BIM analytical model. And then we need to, well, we have some files in this project. I have some extra files from other applications that I've exported before, but I'm not going to use it. I'm going to read only the analytical model. We can here select the groups of spaces that we have created in the analytical model. In this case, the use units. And now the same, we are going to read the Open BIM analytical model, not the architecture. Okay, going to show all the elements. Okay. So here we have the analytical model. Okay, better. Okay. Yes. So this is the model, but in terms of analytics. Okay, we don't have solid walls, we have only the surface. Okay, what we have when we are in Acrobat by type, I'm going to explain you this software before the general data, and after that we are going to work with this model. So what we have to do here in Acrobat by type? Well, we need to set the general parameters. In this case, we can set here the general options for example, the acoustic indices that we are going to use in order to calculate the different parameters of acoustic, like airborne sound insulation, airborne sound insulation against outdoor sound or between rooms, internal or external. We can set the index for the impact sound insulation. Okay, it has some indices depending of the requirements. Okay, the magnitude used for the increment noise level, I mean the sound pressure level, and the calculation of some extra information in order to know how to calculate the sound pressure level. And the same with the facades. Here we have some help options in order to know what we are going to do. Okay, this is only to calculate to set the acoustical indices. Then we can introduce type of equipment noise, like continuous, intermittent. Okay, and then as we have it, we can assign these typologies into the equipment in order to divide it in different type of noise. We can introduce space types for acoustics, and each type of space in AcuBat has different requirements. For example, we can set requirement for outdoor noise. In this case, we use the index that we have defined previously, but we can set here the limit value. The same with airborne noise from adjacent buildings, and some options in order to make the software knows about the source emission, if we want to consider those types of spaces as an interdependent without taking into consideration the use unit, for example. And if we want to calculate the indirect airborne noise across this space, for example, for a corridor. We can introduce some conditioning limits for revelation time, okay, depending on the volume, we have some threshold values, and the same with the absorption area. Okay, we can set different values, different limits with unfurnished spaces and with furnished spaces, but it's the same configuration. Okay, and finally we can introduce limits for equipment noise that we had to introduce the functioning before. And then we have the interaction between spaces, but as we haven't introduced spaces before, we can say. We have some ways to fill this information. We can introduce it manually, as I was doing before. We can use some national standards, and here we have some samples, for example, from Spain, France, Portugal, Italy, and Brazil. And if we select one of them, we are going to import all the information of these typologies for this regulation. Okay, but well, for this webinar, I have created one personalized configuration. I mean, I did it before, introducing all the spaces here, and I save it in a file. You can do it too. If you have a different regulation, you can introduce it manually, export it, and then you can import it in all the projects. Here we have a default. I show you a default file. And here we have some typical spaces for protected, habitable, common areas, stairs, technical rooms, conference and classroom, restaurants, and noisy rooms. For example, for a protected, we have limits for airborne noise, external from the adjacent buildings. Sorry, we don't have nothing about the sound conditioning, and we have some equipment noise limits for continuous, intermittent, and emergency functions. For example, in a classroom, we have some conditioning. Okay, in classroom with a volume of less than 350, we have a value between 0 and 0.7 second of revelation time, and a different value with the furnace, a different limit. And finally, the interaction between spaces. Once we have all the spaces introduced, we can introduce here the limits of internal noise, airborne, and impact. Okay, we have some example here. For example, a protected room with some emitters, like another protected room, another habitable room, common areas, stairs, technical rooms. Okay. So I'm going to accept it and to accept it again. And now we can go to this project. Those general parameters, we can create it for all our projects. And now we are going to define the libraries of this project and all the projects that use the same typology of elements. Okay. For example, I have all these elements assigned because I'm using the same typologies in all my projects. So for example, I know that a bedroom is a protected room in acoustics because I did it before and I export this information in a file. So once we create a new project, we have this link automatically assigned. For example, I have imported here a bedroom type, and I know that it is a defined space, and this is a protected acoustic space in terms of this configuration. So I don't have to do this this link again. We have this bedroom and protected spaces. The bedroom, you can see it here in the 3D view. Those are the space types that we have created in CYPE architecture before. Okay, for example, if I go to CYPE architecture, I have it here. And I press here, you can see that this is an F3 circulation with type circulation. So here in Acrobat, you can see that we have these circulation spaces, which are all of these. And we need to say that a circulation space in terms of architectural model is a common area in terms of acoustic model. Okay, so we did with all the elements, we have to exclude the external spaces. Okay, and you can see we can exclude also the leaf. Okay. This is for the spaces. Once we have the spaces, we need to configure the construction elements. I mean, facade, partition, basement walls, screens. Okay, so we are going to pass to the facades. We have two types of facades in this project. This EF25 and this EF15. Okay, for this EF25, I created before an assignation. What we have to do here? Here is where the CSTV database appears. The CSTV is the company that we develop this application. Okay. I'm going to press here in the toolbar to show you the entire database of CSTV. The CSTV are a company that are available to make a laboratory simulation of the acoustic products. For example, if we press to masonry, we have some products. Okay, for example, here we have a general description. This is a generic product, and we have some performances. For example, the sound reduction index. We have all the values in 1/3 octave bands from 50 Hertz to 5,000 Hertz. Okay. We can see the global values here in the ISO standard and in the STM standard. And the same for the association coefficient. We have some generated products and some manufactured products. Okay, those are real products from manufacturers that have been measured in the laboratory, as you can see here. For example, we can show the partition walls. Okay. And we have other type of subfloor coverings, block coverings, for example. Now we change the indices. We have the reduction of impact sound pressure level, the improvement of the sound reduction index. We have walls, also we have windows. Okay, so there's a lot of type of products. And if we don't have the product that we need, we can insert it. We can copy a product, modify it, and introduce a new product. Okay, a user product to use it in a project. It could happen if you have a different product. We have more than 2,400 products here. But if you have a new product and you want to introduce it because you have the performance, you can do it, copy one. If you have a window, you can copy a windows, and you can introduce the properties, the names, and change the values. And after that, you can use it in all the project because this database is stored in your computer. If you want to look for a specific project, a specific element with a property like the acoustic reduction index, we can look for it. For example, we need to a product with 45 decibels acoustic reduction index, and we can filter all the elements to show it. Okay, now we are going to show only product with more than 45 RW. So this is more or less the database. We have some tools to compare elements like this. Okay, where we can compare the spectrum, and we can change the way as we show the product from origin to manufacture. So here we have all the manufacturers that CSTV have in this database. And then we have the generic product for here. So I'm going to close this full database and I'm going to select an element. So for example, here in the facade, we need to choose a base element and optionally internal lining and an external lining. So to select the base element, we press here in the database button. And now we don't have the entire database, we have only the element that we can use for a facade. So here we have a base element of hollow concrete blocks that I've chosen before with this spectrum. Okay. And I add an internal lining here with some properties. Okay. All of these we can export it into PDF, docx, text format, HTML, or RTF in order to justify those products. And the same with the external line. Okay. You can see here the product and the values. So the same that I did with the FC25, we did it with the EF15, but only with external lining, and we didn't add an external line. When we have defined both typologies, we can export it into a file in order to import this link in the next project. So if I create a new project in the CYPE architecture or in other modeler, and I introduce a wall with the reference EF25, we will have this assignation totally automatically. So when we, as you can see in this point, when we start a project with those typology of element, we will have this, for this EF25, we will have this base element with those internal and external line. So this is for the facade. For the foundation are exactly the same. Okay. For the basement wall, we only have internal lining. And for the script are some different. For the skip and for the skip, for the slab and roof, I mean for vertical dividers. So instead of having internal and external lining, now we have top lining and bottom lining. So for example, for this for the slabs, if we select the base elements, you will see that we have different types of elements that we can use here. For example, we have some elements that we can use in walls and in slabs, that is concrete walls and slabs, and some of them we can only use in vertical elements, like in horizontal elements. I mean vertical dividers, like floor constructions elements, precast shuttering slabs, hollow core prefab floors, and some roof constructions. Okay. And same we have in terms of top lining. The product that you can use as a top lining are different from an external and internal lining. So you can see here some floor coverings. And if we can introduce a bottom lining, it's the same. We have some subfloor coverings. Okay. and some insulation that you can use also in walls like this. I'm not going to introduce it. Okay, so it's exactly the same. For skids, we don't have bottom lining, and for roof, we have both. I'm going to delete it because it's not in use, but the reserve. Exactly. And after that, we can introduce doors, windows, and skylines. In this model, we don't have skyline, but it's the same with doors and windows. For a door, we only need to introduce a data, a base element. For example, in this case, we introduce a external door from a generic product with this value for sound reduction index. And for example, for this, we have a product of a manufacturer with a different indexes. Okay, this is only to choose one product, and the database is only showing you doors and windows. And if we go to Windows, we have the same for the data, and we can introduce a BIM box. From the BIM box is the products, for example, and a air inlet too. Okay, you can see here. So this type of acoustic leakage are important for the acoustic insulation in terms of airborne noise. After that, we can introduce skylines, but we don't have it in the architectural model. And then we can introduce air inlets manually, connections. The connections, the air inlets are only introduce air inlets into a wall instead of putting into our windows. We can the connection have been read from the analytical model. So we don't have to do anything here because we already have it. The absorbing layers are elements that increase the acoustic absorption properties, but they are not going to modify the insulation properties. Then we can introduce furniture. Okay, like standings in order to increase the acoustic absorbent area and reduce the reverberation time. And finally, we can introduce equipment. I'm not going to introduce it here because we can read it from other applications like CYPE HVAC ductwork or CYPE HVAC hydronic. But if you want to introduce it, you can introduce here a continuous equipment. You look for a source, for example, a head pump. Okay, well, I'm going to put one. Okay, for example, the head pump. And then we can use it as the same of the rest of the element. If you use a tube, you can use a service shaft as cladding. Okay, but it's not there in this case. Then, when we have the libraries, we can go to the real elements, these use units. Okay, in a use unit, we have the spaces. Okay, the spaces of one use unit. And in each space, we can see their walls. Sorry, their walls. There are walls in this space and in the adjacency spaces. We have the floor slabs. Sorry, because there are a lot of elements here. Okay, now we can see it. And some connections. Okay. We can introduce in this room furniture or, for example, equipment. I'm going to introduce this head pump inside of a room, so it's going to destroy the acoustic, but okay, I'm going to put it. And you can see that what is F5B bedroom 2 have some pressure level. So when we have defined all the elements, we can introduce all the sources. We can check the properties of the elements, but we have reading from the BIMserver.center file from CYPE architecture, and then from Open BIM Analytical Model. So this association is already fixed. We can add information like new spaces or outdoor equipment here in this outdoor equipment position in order to introduce equipment that are out of the spaces. But when we have all this definition, we can go to the second tab, the Analyze tab, and make the calculation with this Analyze. When we have calculated, we have a resume and analysis summary with all the rooms and another view of the project. For example, this project protected insulation against airborne noise with other protected rooms. We can see that all the spaces are inside of the limits. Okay, for example, if I change it for common areas, I mean, this is a protected as a receiver with a common area as a emitter. So here we have some spaces that are out of the limits. Okay, and the same with the every tables, with the stairs, the common area, with the protected rooms, and with the technical rooms. Okay, this is an overview, and now we can go to each room in order to see the properties. For example, I'm going to go to the 5B here, that we have also the equipment noise. And we have all the parameters dividing typology. For example, we have the external noise with 2 facades, and 2 separators, indirect, and all the lateral paths. And the same with the other separator, the direct, the opening, and the rest of lateral paths. If we want to see the entire calculation, we can go to here. We can see the global values, the final value in the index that we have set in the general data, and the required value. We are inside of the limits. It's verified, and we can see here the results in terms of octave. Okay, in 3 types, we can see the results here in this view, in a table, and in a graphs. The same, we can export all this information in several formats, and also in Excel to carry on in Excel, for example. If we want to see only the information of a lateral path, we can go here and see this information only in the lateral path. We can see the entire lateral path, only the direct flanking path, for example, and only the calculation of this difference velocity in the jointing. We have here all the formulas, how we calculated, and the relationship with the standard. Okay, you can see here this is generated KJ knowledge output from camera and jack. We have here the calculation method. Okay. This is for the external noise, and exactly the same with internal, but here we can see the meter in yellow. Okay. So for example, for this bedroom, we can see the separator, the direct path, and the different lateral path. The same with impact noise. We have the separator and the path, and this lateral path, for example, and this other. Okay. And finally, we have this service equipment noise of this sound that I introduced manually So you can see here that the compressor level are out of the limits, of course, because I introduced a head pump inside of a bedroom. Okay, but you can see here the results and how we have calculated. I think it's better here. Okay, we have the formulas and the values. Oh, well, it's different. I mean, we have the impact noise, then we have changed the indices, the LNT, the DNTA for the inside internal airborne noise, and if it is required, if the value are inside of the requirements. And for all the calculation, we can show the entire results with the values in octave bands, and 1/3 octave bands. Finally, when we have checked all this information, we can show the general report. For example, the report of the entire project. We introduce summary reports. And here we have all the calculations of all the rooms and the values. Okay. I didn't show you, but we can calculate also indirect transmissions. Maybe not in the room, but for example, in this, we have an indirect transmission between the stairs across the circulation. Okay, here are an indirect transmission. We can generate a material properties report with all the properties of the acoustical of the material from the CSTV database, and a metal shader with a resume of the association between the architectural type and the acoustical type of elements. For example, the AF15, which we have 261 square meters, is divided in a base element with the properties and an internal cover with these other properties. Okay, this is the composition of those architectural elements. And if you want to see the real properties of this file, this product, we can go to the other report and see the properties. Once we have all the reports and we have checked it, we can go to model and export it. Okay, if I export it, we can create another file. In this case, it's acoustic analysis. I accept it. And we are going to generate the reports and to export it into the BIMserver.center project. So we accept it. And we go to BIMserver.center again. We go to content. I don't know if it's been uploaded yet. I think so. I can see. Yeah, I don't remember where I exported. Open BIM. So maybe it hasn't uploaded the model yet. Here, this is the acoustic analysis a minute ago. So we can go to here to acoustic analysis, and here we have the 3 reports, the results here, okay, and the same with the rest. So this is important because this information is shared with the rest of the team. In this case, I'm alone in this project, but you can invite a user, a collaborator, and he will have the option to see the results of this acoustic analysis. So I think this is more or less the overview of the Acrobat by SYPE application. I would like to, I think I passed the time, but I would like you to know that we have some examples in Acrobat by SYPE and also in the rest of applications. For example, here in Open BIM Analytical Model, and of course in SYPE Architecture, where you can look for some examples that are already designed. For example, this hotel in acoustics, this technical school in Open BIM Analytical Model that is a building from Untitled Chapter. And in this acoustics, in SYPE Architecture, you can look for other type of building. Okay, so you have some examples. For example, this hotel in acoustics, this technical school this is the sample of Untitled Chapter. So you can see here the building element and then the analytical elements. The same in acoustic, you have see the results, and in SYPE Architecture, what you have here, and other samples that you can use in order to learn about the workflow and to test it without not knowing what you are doing. But for example, with this building, you can test directly Acrobat without design a new building in SYPE Architecture, for example. Only joining into a new project and export this information. And with this, if you go directly to Acrobat and open a new sample, where you can see the results of that sample to understand the type of measures that measurement that Acrobat by SYPE is available to run. Okay. In this case, we have also service noise from an application of HVAC. So this is more or less the webinar that I have prepared to you. So I don't know, I didn't see any questions. So if you have some questions to make it in according to this, you can do it in the go to webinar tool. But if I don't know if I'm not the owner. Yes, I'm there, so I will see. But if you have more questions, you can send it to us by email to our technical support department, and we will try to we will answer you, of course. So anyway, if you have some question after that, you can send it to us. Well, that's all the presentation that I have prepared. I hope that you enjoy it and you learn some about this workflow and how it works and how it could help you in order to reduce time and to increase the organization of an acoustic study, and the precision also, because we try to do this Open BIM workflow in order to reduce the possibilities of making any mistakes in order to pass directly from the architectural model to the specialized tool, in this case the acoustic analysis tool, with this Open BIM workflow through this BIMserver.center platform that prevent the losing of information. So well, I think that Vicente, my colleague, have written before in the chat some information about where to download the application and where to send the questions. So if you have any question, you can make it here, and I will be glad to answer it.
There's a question, Victor. What about acoustic input data for different materials, timber, CLT, and so on?
Okay. Well, we know that from the CSTV they are developing some new material. Well, they are testing some new materials like CLT and timber. But if you have some information and you want to introduce it, you can do it editing the database. So, for example, here. Internal walls. Sorry, I did it. Okay, here. Now, for example, this internal noise, we have here timber frame, and we have some elements, little elements. As I mean, we have 2 elements. But if you want to introduce new, you can copy one and introduce here a new element. For example, well, the property that you have, you need to introduce a new element that is not one of them. And of course, we can. I have read I'm reading another question. If we can calculate reversion time, of course, we calculate reversion time, but in terms of a building code using the Skylines formula, you can see it here, for example, in a common area. Well, I changed the example, maybe. Yeah, here we have the value of A of the acoustic equivalent absorption area. But well, we can introduce a new parameter, for example, to calculate the reversion time in common area. Now I'm changing the general data to calculate reversion time instead of, well, with the acoustic absorption area. Okay, we need to run the calculation again. Okay. And now here we have the reversion time with the round unfurnished and furnished, but why we didn't introduce furniture in this common area, so it's the same. And if we go to the formula, we can see the calculation with the absorption coefficient properties of the products and the volume of the space. We calculate the reversion time. Okay. The same, we can see the global value in this standard result report on in a table with the area, the equivalent area, and the reversion time in one of the bands, and directly in a graph. But in this case, it doesn't make any sense to show this reversion time in a graphs. Okay. So maybe this is the report with more information, but yeah, this is where you can check how the calculation has been run. So yeah. So if you don't have any more questions, I think we can finish this webinar. I think that we will send you an email with the recording to check it again if you want. And well, I think this is all for my part. As I said before, I hope that that make it useful. So be free to send us any questions after that, and we will answer it to you. So thank you very much, everyone.